Chapter 9. So first talks about polar coordinates. So we have polar, and then the ones we're used to, rectangular. So rectangular coordinates are in terms of x and y, whereas polar is in terms of r and theta. So some of the formulas we're going to need in order to convert between the two. So we have x equals r cosine theta, y equals r sine theta, r is equal to the square root of x squared plus y squared, and theta is the inverse tangent of y over x. Okay. So, for example, let's say we want to convert the point 3, 4 into polar. So r is going to be the square root of 3 squared plus 4 squared, which will be 5. And theta will be the inverse tangent of 4/3, which will be 53.13 degrees. So my point will be 53.13 degrees. And then if we want to convert polar into rectangular, so we want to go the other way around. So now we're given the point 7 5 pi over 3, and theta can be both in terms of degrees and radians. This time I did it in radians. So x is going to be 7 cosine 5 pi over 3. Y is going to be 7 sine 5 pi over 3. And we get these. This will give me 3.5. And this will give me negative 6.06. So my point will be 3.5, negative 6.06. Right. Right. So polar equations and polar graphs. So polar graph will be in this form. R equals 1 plus 3 sine theta. Right? So if we want to graph this, we would have to use values of theta that go from 0 to 360 degrees. Okay. Okay. So let's look at a quick graph and here we'll be using Desmos to do this. And so let me change my screen here. So now we should be looking at Desmos.com, and we want the graphing calculator. And we want, this is a rectangular grid, so we need to change this to polar. So we click on the little tool here, and we go to polar. And there we go. Now we're going to type in our equation. So this is going to be R equals 1 plus, and then down here, my little tool typewriter here, we want functions, and we actually want 3 first, so we want 3, and then we want sine, and then we need the theta, so this ABC thing, and we pull up our theta, and we get our graph. Right? So polar graphs, you get some pretty interesting shapes like this. Okay. So in your book on pages Let's go back to my screen here. Let's go back to my main screen. On pages 595 to 596, they talk about different types of polar equations and their graphs. So they give you sort of a summary of some of the basic graphs and what they look like. Okay. So polar. Right? Well, then we can also talk about complex numbers. Which are going to be in the form of a plus bi. We can plot those on an axis. So we could say that this is going to be the real axis. This is the imaginary axis. And if I want to plot the point 3 plus 4i over 3 of 4, and there's my point. So we can have a rectangular form, which is the a plus bi. We can also then have the polar form, which is going to be r cosine theta plus I sine theta. So if I take the same point, 3 plus 4i, well, r is going to be the square root of 3 squared plus 4 squared. That'll be 5. Theta is going to be the inverse tangent of 4 over 3, which we said before gave us 53.13 degrees. And so this would become 5 cosine 53.13 plus I sine 53.13. And we get our point. So we got rectangular form, we have polar form, we can also write it in another form, and that form is exponential. And in this form we have REI theta. But here theta has to be in radians. So 3 plus 4i is the same as saying 5 cosine 53.13 I sine 53.13, which is the same as saying 5e 0.927i. Sine of 53.13 degrees is the same as 0.927 radians. So then we talk about in terms of some operations with these numbers. So first off, multiplying and dividing. So given that z1 is in the form of r1 ei to the theta 1, z2 is in the form of r2 ei to the theta 2, then z1 times z2 is going to be given by r1 ei theta 1 times r2 ei theta 2, which is going to be r1 times r2 ei to the theta 1 plus theta 2. And then if we do division, and let me fix this, this should be z2, and so z1 divided by z2 will be R1 EI theta 1 divided by R2 EI theta 2, which will be R1 over R2 EI theta 1 minus theta 2. So multiplying and dividing. So let's look at an example of each one. So my example. So given one of the Z1 is 4e pi over 3i, Z2 is 6e 5 pi over 6i. Then that would mean that Z1 times Z2 is 4e pi over 3i times 6e 5 pi over 6i, which will give us 24. And then I add those two together. Pi over 3 plus 5 pi over 6, common denominator would be 6. So that would be 2 pi over 6 plus 5 pi over 6 will give me 7 pi over 6i. Right? And then if we do the other one, which is Z1 divided by Z2. So now I get 4e pi over 3i, 6e 5 pi over 6i. Now this will be, in terms of this one, we'll get 4 over 6. So this is going to give me 2/3 e. And we're now going to have pi over 3 minus 5 pi over 6. Well, pi over 3 again is 2 pi over 6. So 2 pi over 6 minus 5 pi over 6 will give me 2/3 e minus pi over 2 I, which will be the same thing as 2/3 e 3 pi over 2i, if I write it in terms of a positive angle. Okay. And then you should be able to convert that into polar form, and then you could also convert that into rectangular form. Next thing it goes into is the Mowbray's theorem. And z to the n is r to the n e I n theta. So as we want to find the complex fifth roots. So I end up with minus 1 plus the square root of 3i. Well, the first thing I need to do is change this into exponential form. So r is going to be negative 1 squared plus the square root of 3 squared. This will give me 2. And theta is going to be the inverse tangent of square root of 3 over negative 1. And I do that in radians. This will be 2 pi over 3. Okay. So we have 2e to the 2 pi over 3i. So now we get all our roots. And so we get z naught is going to be the fifth root of 2 ei, and then this is going to be 1/5 2 pi over 3 plus 2 times 0 pi, which will give us the fifth root of 2, e to the 2 pi over 15i. Right? Z sub 1 will be the fifth root of 2, e I 1/5. This will be 2 pi over 3, 2 times 1 times pi. And so this will now give us the fifth root of 2. I'm not sure where that 3 came from. Let's change that. So the fifth root of 2, e, and now this is going to give us 8 pi over 15 times I. Right? Z sub 2, right, is going to be, so there is going to start to be a pattern here. And the pattern is this, is that this is now going to be the fifth root of 2, e, and this will now be 14 pi over 15. So basically the pattern here in this example is we're going up by 6 pi from one to the next. Z sub 3 is going to be the fifth root of 2, e to the 20 pi over 15i. And then lastly, Z sub 4 is going to give us the fifth root of 2, e, and this will be 26 pi. Right? So we get all of our values. Right? So once you get the first couple, you'll notice there's going to be a pattern with the angle. And after that, we'll continue on. And if I do it again, I've gone around the circle. Actually, if I do it again, it'd be a 32 pi over 15. And 32 pi over 15 would take me back to my starting point. 2 pi over 15 is what that would become. Right? All right. Next thing is vectors. So we have vectors. So we have a vector like this. V equals 3i plus 4j. We have another vector, W, equals 6i minus 2j. Right? We can graph vectors on our xy axis. Now we call this I, now we call this j. Right? So V would be going something like this. This would be V. And then W would be going something like this. Right? So given vectors, we can add them, we can subtract them. So if I did V plus W, this would be 3i plus 4j plus 6i minus 2j. And so 3i plus 6i is 9i. 4j minus 2j gives us 2j. Okay. And we could also do subtraction. If I did V minus W, this would be 3i plus 4j minus the 6i minus 2j. And so 3i minus 6i is a minus 3i. 4j minus a minus 2j would be 6j. Other rules, well, if I do V plus 0, we just end up with V. And we do V plus a minus V, we get to 0. Okay. We can also multiply by a scalar. So if I said 5V, well, that'd be 5 times my original vector V, which will be now 15i plus 20j. If I did negative 3w, well, this would be a minus 18i plus 6j. So we can multiply by a positive or negative number. Okay. Another way you can write a vector, a vector, try that again. So another way, given 2 points, starting point, end point, the vector would be x2 minus x1, and then y2 minus y1. So if I had the point 2, 5, the other point here is 4, 7, then my vector is going to be 4 minus 2, 7 minus 5. So this is going to give us 2, 2. Okay. And then the magnitude of a vector, which really is how big is it, the magnitude of V is going to be a squared plus b squared. So if I do my vector, which I had before, which was 3i plus 4j, then the magnitude of V is going to be 3 squared plus 4 squared, which will be 5. Other thing with vector, we can have what is called the unit vector. And so the unit vector is U is given by V divided by the magnitude of V. So again, we have the one I've been using, which is 3i plus 4j. We said the magnitude of this was 5. So U is going to be 3i plus 4j over 5, or 3/5 I plus 4/5 j. Right? Other ways we can write vectors is we could say the vector V is given by the magnitude, and then if we know the angle it goes off at, we can use this. Okay. So let's say if I have a vector, we know the magnitude is 9 and the angle is 50 degrees. So that would mean that V is going to be 9 cosine 50i, and then sine of 50 degrees j. And we can multiply that out. 9 cosine 50, this would be 5.79i plus 3.83j. We also then get in terms of a thing called the dot product. And so V dot W is given by A1 times A2 plus B1 times B2. So if I'm given that V is 4i plus 9j, and W is 8i minus 10j. Let's see, minus 10j. Try that again. Minus 10j. Then the dot product is going to be 4 times 8 plus 9 times negative 10. So that'll be 32 minus 90, which will give us a negative 58. So we get our dot product. Okay. We can then also get the angle in between our two vectors. And so the angle between two vectors is theta is going to be the inverse cosine of the dot product divided by the magnitude of the two vectors. So let's use the one we were just using with, and so we had v was 4i plus 9j, w was 8i minus 10j. The magnitude of v is square root of 4 squared plus 9 squared. And so this will give us the square root of 97. And then the magnitude of w will be 8 squared plus the negative 10 squared. So this will give us the square root of 164. So then theta is going to be the inverse cosine. My dot product, which we said earlier was negative 58, divided by the square root of 97 times the square root of 164. And we plug that in, we get an angle of 117.38 degrees. Would be the angle in between my two vectors. So, two vectors are orthogonal. And really this means that they're at right angles. If v dot w equals 0. So if the dot product is 0, then they are orthogonal to each other. So you get in terms of some physics applications. So work is given by f d cosine theta. So you get a question like this. So you have a force of 200 pounds is applied at 40-degree angle for 50 feet. And the question then is how much work is done? So work is going to be 200 times 50 times the cosine of 40. And we plug this in, we get 7,660 foot-pounds of work. So we have in terms of the XY system, and so then the chapter finishes off in terms of the X, Y, Z coordinate system. So now V is given by AI plus BJ plus CK. So given point 1 is given by X1, Y1, Z1. Point 2 is given by X2, Y2, Z2. Then the distance, D, is given by X2 minus X1 squared plus Y2 minus Y1 squared plus Z2 minus Z1 squared. So an example of this, given that P1 is the point 4, 3 minus 5, point 2 is 7, 12, 4, then the distance, D, is the square root of 7 minus 4 squared plus 12 minus 3 squared plus 4 minus a minus 5 squared. So this is going to be 3 squared plus 9 squared plus 9 squared. So we end up at the square root of 171. We can also get what is called the unit vector, and the unit vector now, it's not the unit vector, but the magnitude rather. The magnitude is going to be given by the square root of a squared plus b squared plus c squared. And the unit vector would be given by w over the magnitude of w. Right. 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 So those two, right? Right. And then we can also find the dot product. And so the dot product is given by, so v dot w, a1 times a2, b1 times b2, and c1 times c2, right? So all these formulas are really the same as we've seen before, except we're now added to a third dimension. And we can also do the angle between the vectors. And that formula, theta, is the inverse cosine of the dot product over the magnitudes. So now that we're talking about a vector in three-dimensional space, we can have the direction angles of a vector in x, y, z space. So cosine alpha is given by a over the magnitude of v, and this is with regards to the x-axis. Cosine beta is given by b over the magnitude of v. So this is with regards to the y-axis. And then cosine of gamma is c over the magnitude of v. And this is with regards to the z-axis. And then the last thing, then it finishes off with, we had dot products, and now we have cross product. And so v cross w is given by b1 c2 minus b2 c1 I minus a1 c2 minus a2 c1 j plus a1 b2 minus a2 b1 k. So given that v is 5i 7j minus 10k. W is 3I minus 5j plus 6k. Then my cross product, V cross W, is going to be the 7 times the 6 minus the minus 5 times the minus 10 I minus the 5 times the 6 minus the 3 times the minus 10 j plus the 5 times the minus 5 minus the 3 times the 7 k. So if we do this out, this is going to be 42. This will come out to be a minus 50, that part. This is going to be 30. This will be plus 30 on this side. And then this will be a minus 25, minus 21. And so we're going to have a minus 8i minus 60j minus 46k. And that will be our product. And that will conclude this video.